thanks for having me. So this paper is about social interactions, mechanisms, and equilibrium. And basically what we do is we have some really nice data, and we build a model that is sort of the bare bones we need to help to think through the data, think about the data, and tell a nice story. So that's what this paper is about. And this is joint work with my colleagues at Western, Tim Conley, Ralph Steinbrickner, and Todd Steinbrickner. Okay. So all we're trying to do is improve our understanding of peer effects or social interactions. There's been a lot of research that documents the existence of a relationship between, very broadly speaking, one's outcomes and the characteristics or outcomes of one's peers in lots of different contexts. And our impression was that there was a lot less evidence about why it's actually better to be around better peers, right? So, and in particular, there's very little direct evidence or almost no direct evidence about the mechanisms through which peer effects arise. So there might be evidence that are sort of like testing implications of a certain model of peer effects, but not really with direct evidence on the mechanism of interest. So in our paper, we're just going to consider input choices as the primary mechanism, and I'll be more clear about that soon. So another natural next step is to allow social interactions to spill over to all agents in an economy. So what we mean by that is that, again, our reading of the literature is that studies often estimate policy functions or best response functions, right? So my peers do something that affects me in this way. But sort of just naturally, people might be embedded on a social network, and so estimating best response functions might sort of not give you a true picture of the heterogeneity and kind of interesting interactions that are available for us to understand. Okay? So what do we need to do this? Well, we need a framework that actually lets us embed a mechanism of heterogeneous feedback effects in equilibrium, right? And we also need data on inputs through which the mechanism arises and the entire social network. And this is really the sort of innovation of our project. We're not doing anything really. Okay, I probably shouldn't say that. We're doing great technical things as well. But I think we're just basically making use of good data. So it's rare to have data on good data on both social networks and academic inputs. Okay, so for example, Ad Health measures networks, but doesn't really have very good direct measures of potentially important academic inputs. And then lots of well-known data sets like ECLSK or children of the NLS 79 measure inputs, but not networks. Okay, and we also would like data addressing econometric endogeneity concerns. Right. So
can I get a lot of multiple equilibria issues? With models usually have multiple equilibria.
Yeah. So if you're modeling friendship formation, then you're going to have multiple equilibria. You're going to have to do something about that. If you're modeling a game played on a network, then with pretty reasonable restrictions, you're going to have a unique equilibrium. That's what we're going to do. That's what we're going to do here. Yeah. I didn't. Yeah. Okay. So, oh yeah. Okay. It's a ghost, but you'll see it in a minute. So, so what we do in this paper is we focus on a natural mechanism that we think of capable of generating peer effects, which is that friends influence your grades in college by influencing how much you study. Okay, so the context matters, right? So effort might be important in the short run. In college, it's probably not your parents who are, providing the biggest inputs. It's probably your own study time, right? And your close friends are probably the people who matter most in college. But we also examine other potential channels. This is just sort of the focus, and then we examine other stuff along the way as well. So what do we do to do this? We build a model to estimate student best response functions, right? So how much my study time depends on your study time. And production functions, which is how my achievement depends on study time. And these best response functions, like I mentioned, might be heterogeneous. And this is interesting because that actually allows there to be a scope for policy. Otherwise, we're just sort of shifting achievement around, but the total amount of production might not change, right? Then we iterate best response functions to solve for an equilibrium given a social network. So everything is going to be given a social network. And then use production functions to examine achievement. And the idea is that even given a social network, you can still kind of understand a lot about the nature of social interactions, right? Because you can do like an impulse response function and see how equilibrium changes when you change, let's say, pay the most popular student to study more, right? Or just generally how much variation there is between the total gain in the economy from shocking different students. It sounds unethical, but yeah. And then also see how changes that are well specified, like so moving to different fully specified networks affect achievement, right? So we can't model how friendships would change, but we could, let's say, randomly assign friends and see how important homophily is in the actual production of achievement, right? Or even do some hijinks and see maybe what the achievement maximizing network would be, right? Which is something that we could investigate, even if it wouldn't be like sustainable as an equilibrium, we wouldn't know. Okay, so that's what we're going to do, and this is pretty. This is sort of the major technical limitation where we're not innovating. We're taking the network as given, but the nice thing is that we can really make a lot of progress in the ensuing sub game given the network, right? So our paper is basically like, I think, a pretty interesting, arguably interesting, but sort of sub game of some pretty recent other stuff going on out there. Okay, so like I said, a major strength of our paper is the data. So here's a bit about the data. So it's from the BRIA panel study collected by Ralph and Todd Steinbrickner. So the study features 2 cohorts of college students at BRIA, and it has both panel survey and administrative data. And the quality of the survey response is really, really high. It's really good. So BRIA is a liberal arts college located in Kentucky. It's got free tuition. Course loads at BRIA are pretty similar between students in the freshman year because they're basically taking the same curriculum. Okay, so there's not a lot of sorting into like math, chemistry, whatever in the first year, which is kind of nice. Later on, there is, further in their careers, right? But in the very beginning, they're having a very standard liberal arts curriculum. And academically, students at BRIA look similar to other students. Todd's from Kentucky, so he uses University of Kentucky as the as if that's like representative of the rest of the world. But but it is like the flagship public institution in Kentucky, right? So it's not a bizarre place. Okay, so we studied the second cohort during their freshman year for reasons that I'll make clear in a couple of minutes. So the specific features of relevance to this project, the data features. First is that we have study effort 8 times each year from time diaries, which are thought to basically be the best, sort of measure of highest study effort. So that's really good evidence, or really good data about the input of interest. And then we have really good elicitation of social networks, right? So we directly identify the most relevant peers for what we think is the most relevant peers for this mechanism, your closest friends, multiple times each year, and they survey all the students at the school. Okay? So we can really flesh out a good understanding of the social network. And we do it, actually, we show that it's not the same between semesters, let's say, right? So if you had only one measure, then it might get things wrong. Okay? Okay, so here. Oh, sorry. Yeah.
You know how long? Did they ask how long you study with them?
They do. Follow-up question is, do you use that information? And the answer is no. The reason that we don't is that it's actually pretty easy to endogenize that decision given who you're friends with, but it's a bit silly to sort of, take as given that you're friends with them and then choose just how much time to spend. So we just sort of left it. We just don't use that information. It's sort of bordering on. Okay. Okay. So this is how we address econometric endogeneity. So the first part is in the grades and the production function, right? So the typical concern here, again, is so from the context of somebody who does education, is that you usually don't have good data on motivation or study effort, right? So basically, our approach is to collect data on this thing that's typically referee's primary concern in a paper that I write, right? Like you don't see motivation or study effort, and it's like, well, we just have it and we model it, right? So this typical unobserved random variable is no longer unobserved, but in the best response function, right, it still could be that people who plan to study a lot might become friends with each other, right? So this, again, what looks like an effect of of really studious peers is just giving us information about unobserved characteristics, right? So we have two approaches. We, again, ask survey questions about study propensity variables, like how much you studied in high school, and then perhaps more in line with the model, right? How much do you expect to study in college, which you can show basically could be a linear transformation of what this unobserved random variable would be, right? So if you condition on it, then you're basically, that's your control function. But you don't know whether these are going to be any good, right? Or maybe there's some other variable that's actually causing a problem, right? So because of that, because we can't a priori know these questions capture the relevant heterogeneity, we develop a specification test that exploits the equilibrium nature of social interactions. So this is an innovation, although it's sort of taking something basically from another literature and using it for a completely different purpose, but still innovative. So the idea is that in equilibrium, if you have an unobserved determinant of study time, right, then in equilibrium, that unobserved determinant is going to propagate to everybody else in the network because everybody affects everybody else. And that's going to induce a residual correlation that should be detectable. So basically, that's the intuition. And then the question is, do you have power to actually, is there power to actually detect such a thing, right? And do our measures basically, once it showed that you could detect it, do our measures help you not detect it anymore? Please. Oh.
I'm still confused
Yeah.
about especially when I see that with the multiple equilibria, because even if the network is fixed, but you have externality, can't you have coordination, multiple equilibria coordination? Because suppose when everybody studied our good externality, and then, I don't know, there is motivation for everybody, can't you have an equilibrium when nobody studies in the network, and then it's a best response versus when everybody studies?
So we have two conditions that are supported by the data that guarantee the existence of a unique equilibrium. So one is that the best response to zero is strictly positive, and two is that we have weak concavity of best response functions. And so there's a unique equilibrium.
Because in general you do have like
for sure.
But it's the okay.
Yeah, for sure. Yeah, but okay, sorry. Yeah, so given a network, there are two conditions, and they're both supported by the data because you can right. So basically, like fewer than 5. It's like 3% of the observations have the best response, or have a study time of 0. So the best, so basically have positive intercept. So you don't have a zero equilibrium, and but I'll get more into it later. But yeah,
Otherwise, like
for sure. No, for sure. So yeah. So we did put some structure on. We did impose some restrictions, but they're pretty they don't seem to do too much violence to the data. Yeah.
So this argument you just made.
Yes.
What are you assuming about the correlation of these unobserved determinants across the friends in the study group? So it seems like you are making an assumption that if you have some unobserved determinants or some realization of an unobserved determinant of one person in the group, that's somehow not correlated with the realization.
No, we're not making that assumption. So, but I'll be more clear. Yeah, I'll be more clear about that later. But basically, the idea is that it has to be a very specific, it's not exactly like unique, but a very specific orthogonalizing process. Only very specific correlation structures are not going to be detectable by this specification test. I'll give an example based on the empirical adjacency matrix that we have and our estimated parameters. But basically what has to happen is that, I'll talk more about it later, but please do bring it up later when I have had some time to go into it in detail. But if that's not sufficient, because it's a bit detailed. But the answer is that so to be clear though, in an earlier iteration of this paper, we actually did make some sort of non-negative sorting assumption, which we thought was pretty reasonable because positive sort of matching is sort of that's what people who are trying to detect causal effects of friends are concerned about. Turns out we don't actually need that, but I'll be more clear about that later. Okay. Okay. So I think I have even more names on this slide than people have skipped lit slides, so I'm gonna skip it. But this is here just so it does a couple of things, I guess, right? So one is that there are a lot of people who study peer effects in education and identification of social interactions models and games played on networks and games where people actually form networks. We're basically touching these, right? And respect people who've done this. and respect these people too, but respect more and from afar people have done this, we'll say, okay? Respect everybody. Children of the earth. Okay, so here are a couple of regressions that just describe the data. Okay, there's some patterns in the data that are motivating. These are not things that we should get too excited about. So the first one is a regression of own study time denominated in hours per day. It's a pooled regression, pooled over both semesters, on your own characteristics and just how much your friends that semester studied. So this is regressing an endogenous, and is endogenous stuff on endogenous stuff, but it would maybe be bad if there was nothing there. Right, so maybe there's something there in the data, and we're going to use our model to try to interpret this kind of correlation. Okay. The second column is a regression of your GPA that semester on how much you study that semester. It's something that vaguely relates to the production function, although this is not the production function. Okay, but again, there's a positive partial correlation there. So something in the data. Okay, and that's really all I want to say about that at this point, because we're going to actually be more serious about those relationships with the model. So now some quick descriptive statistics about, yeah.
Did you say your own study time doesn't depend at all on how much you said you expected to study?
Well, that's only conditional on how much, basically if you leave out how much you did study, then it does. Yeah, so those are basic, we just include them both just because, yeah. Yeah, so this is basically predicted very well by that. Yeah.
So what's the effect of average friend study time on GPA?
The effect of average friend study time on
your own GPA.
ceteris paribus?
Yeah, why is that not included, I guess?
Oh, you want to know what the partial correlation is in this regression? I think it's positive if you included average friend study time in GPA. It's positive, which is what you'd expect. The reason you'd expect that is because, so in the model, own study time is measured with noise. Okay, friend study time affects own study time via best responses. Friend study time is the average over 3 to 4 observations, so it's basically a less noisy measure of your own study time. And so you'd expect a positive partial correlation, which is why I don't really show it there. It's just not. So but just to be clear, we estimated a version of the model where we actually allowed for a direct effect of friend study time in the production of GPA, and did not find a significant.
It's not so implausible that having smart friends tell you how the world works. It's good for you.
That's definitely not implausible. Yeah. So that's why we estimated.
The direct impacts. I guess I'm wondering why you left it out.
So we didn't leave it out with them. So we have a baseline model, in which we sort of went with our priors for what we thought were the most important things, but then like all these different things which are definitely not implausible, let's say, or plausible, we tested for and didn't find evidence of. I'll talk more about that later.
So you're testing for it, but it's what you're going to show us today have a maintained assumption that friends can't the quality of my friends can't directly impact my GPA.
Well, I'll show you. So I have results for a specification in which that's correct, but I have appendix slides and whatever results corresponding to various multitudes of specifications that allow for different ways in which friends would have ceteris paribus effects on my GPA, their characteristics or their input choices. Yeah, but I yeah, okay. Okay, yeah. So here's some descriptive statistics about the network. So we have an adjacency matrix in each time period t. It's going to correspond to semesters, where ATIJ is 1 if I and j are friends, as we define them, in t, and 0 otherwise. So this gets to your question. It's just binary, 0, 1. It's not an intensive measure. So we use the in-cohort friends of the 2001 cohort. The reason is that, see, every student in the school, they list the IDs of their friends. But some of the students list friends, like in the if you're a sophomore, you might list friends who are juniors and seniors. We don't have very good information about you. So using you is not really a very good idea because we want to get as complete a measure of the network as we can. So we use the freshman students who mostly report in freshman friends we have good information on. Okay, so that's why I use the second cohort in the first year. Now, for the results that I have here today, and actually I don't have the appendix slides on these in the presentation, but they're in the paper. We use the union symmetrized JC matrix, meaning that ATIJ is the maximum of ATIJ in the transpose. So if I report being friends with you, then you have to be friends with me. Okay. We've estimated it to other specifications, as in like I allow you to be friends with me and I'm not friends with you. The intersection specification, there are a very small number of friendships there. So things are just kind of noisy. They get similar qualitative results, but very little precision. Okay. But I mean, so it's not. This specification was chosen basically because it seemed to be the most highest fidelity to our mechanism, which I haven't really talked very much about yet. So quickly, churn-in friendships. The probability of basically having a new friendship in the second semester is 1/2, and the probability of losing a friendship in the first semester is around 1/2. Okay, so friendships are not constant. And then all this is saying, this is a correlation between your own characteristic, like whether you're black, and the average of your friends who are black. Male, high school GPA, combined ACT score, high school study time, and expected study time, they're positive. So there's sort of, there's homophily, as people call that, right? People have similar characteristics with their friends.
Is there some way to get at what he wants about intensity by looking at like a min and a max of those? Like, if you've chosen to make, if I like you but you don't like me,
yeah,
we're now friends, right?
Yeah.
But that, you could also do a lower bound in some sense,
right?
Where, so you could kind of get a little bit at intensity, I think, by doing stuff, by kind of trying to look at both of these measures.
So yeah, so I don't have the results in the slides, but basically, the qualitative story is that the qualitative results are pretty similar. When we, let's say, take the intersection, meaning that we both have to report versus only one. Like, I think that's, so they're similar, but the numbers are a bit different. Numbers of what, you might ask? Numbers corresponding to model parameters, which are over here. Ha, good segue. All right, so so the overview of the model is that students choose input study effort to produce human capital. Right, so students are just indexed from 1 to n. We have 307 students for each of 2 semesters. Student types are public, so mu I is 2-dimensional. Okay, so there's this human capital type. Oh, sorry, yeah.
Is there a resource constraint on how many friendships you can have?
No.
I'm a little bit worried about that.
Sorry, you mean economically, or like elicitation in the survey, or like in the economic environment?
In the economic environment.
No.
So if you go back to your matrix, I could in principle be friends with everybody and benefit positively from, like, do you somehow normalize the intensity by which I receive inputs from others?
The mean of your friend's input choice is what enters your best response function.
So if I have 1,000 friends, is the intensity of my friendship somehow normalized by that number, or?
Yes, because it's just the mean of your friend's input choice that affects. It'll be clear in a second, but yeah, that's true. Yeah. Okay. So there's a human capital type and a study type. Okay. So these mu's are predetermined. They're public information. They're basically based on stuff that was collected right before the first semester started, the freshman year. Okay. Which is nice for like the high school study time, expected study. Those are pretty salient at that point in time, right? Okay. So it's a one-stage game repeated in each of the 2 semesters, T1 and 2. And just, it's a very simple model because this stuff is predetermined and it's just fixed. Basically, the only thing that's changing between semesters 1 and 2 is the JC matrix. Okay. And for simplicity, that's not necessary, but simplicity just assume that everybody knows the path of the JC matrix over time, just so we can wrap our heads around it. But it's not necessary because everything's going to be separable. Okay, so within a semester, who's friends with who is determined so that we know who's friends and the characteristics of everybody and everybody's friends. Students simultaneously choose their own study time. Human capital is produced, then measurement errors for study time and human capital are realized, and it's a pure strategy in Nash equilibrium. Okay, so here's our production function. So this is a spare production function, but we embellish it with pretty reasonable things later, and it doesn't really change much. So human capital for student I in period T, it just takes your study time and your human capital type, and spits out achievement. Okay, so yeah, that's all I want to say about that for right now. So our mechanism for peer effects is that peer study time may reduce one's own cost of studying, right? So the story is that it's more fun to study at the library when friends are at the library. There are other mechanisms that are observationally equivalent. Conformity is observationally equivalent. Ironically, we did not conform in just calling our mechanism conformity. Would have made some referees happier, I guess, at some point. But studying is costly. So the cost of studying depends on your own study time, your friend's study time, which is just the average. So what we did, but to be clear, we estimated a specification where we allow for there to be something between the total and the average. And what I can say is that, in the support of the data that we have, like basically found it to go to the average, like go to the corner at the average. So we estimated a parameter, right, that basically allowed it in the denominator, and went to the average, so we just fixed it at the average and fixed it at that. What we see in the data is that the maximum number of friends is 10, so that maybe nobody has 307 friends. But just to sort of try to follow up on that question. The survey question, you can list up to 4 friends, but then when we symmetrize it, it could be that every person lists you as a friend, so it could be, in principle, it could be that 307 people think that you're their best friend or something,
Erasmus, can you just add, so you have both the average study time and then just the number of friends?
I guess.
Affecting, yeah.
Right. So I guess I like the specification where it was something between, we estimate a parameter that governs how much between the average and the total it was. But yeah, we could also, and I guess because we found that it went to average, I would expect number of friends would, but I don't know, because it would be slightly different variation, I guess. That's true.
I know you're not interested in the network, but it seems like...
I'm very interested in that.
No, in the formation of the network.
Okay, sorry.
It seems like you would benefit here from just having a single really high study friend, right? Once you begin to add more friends, then it's hard to get them all to be high study effort, right?
So the number
So with a given network, you could very well imagine that what you care about is not necessarily the average, but what you care about is the max.
Sure.
Have you thought about, instead of using the average, using something like the max among your friends?
Yeah, for sure. I've thought about it. Yeah. That would be as well behaved as this would be, because as long as you have, okay. So define this as some function, right, of the list of what your friends are doing. So define that as some function, but the scalar, right? Okay. So that object now enters the cost function in this way, meaning that there are interactions between what you do, your effective study type. This is just a wrapper to sort of help parameterize. Okay, but basically your study type, how your propensity to study is in there. Okay, so this gamma mu is your effective study type. Okay, and then what your friends are doing, which could be, let's say, the max, for example, right? So, and then this tau is just it's very standard. Just it's no greater than 1. Okay, basically that's our weak concavity. You'll see in the best response function in a minute. So if this was the max operator of that list, then this would be as well behaved as if it was the mean. Oh no, I just verified that it wouldn't be a problem, but you'll see, yeah, it wouldn't be a problem theoretically. You'll see a lot in this paper. It's because we've estimated. This is very different from the typical structural thing that I've done, where things are so computationally complicated so quickly that I have to start making some maybe really austere, I can't ever do this kind of thing. here there are lots of things that we know that we could do, and we just haven't done yet. But yeah. Okay. So here's the student problem. So they choose effort once per period to maximize their objectives. And so here we go. So it's separable, and that's why we don't need to know the AT beforehand. Okay. And so here's the best response function, right? So we impose the realistic, you can't study more than 24 hours in a day, right? So that gives, so you have a slope no greater than 1, and then, right, if you do hit that corner, then you're just at 24, okay? Which is actually really useful because there are some papers that they don't have data on inputs, and then they have to impose these regularity conditions on centrality measures and all kinds of things. Like, we don't need any of that, right? We have a very well-behaved game because we actually observe the thing that they're choosing, okay? Which is really, it sounds like an absurd point, but this is something that actually apparently, yeah.
So is there any role for dynamics? Like, I choose today to study because tomorrow, better skills, and then I reduce the study tomorrow, but I still do better.
You mean any room in this model, or in the real world, do you think that that's important?
Both. Oh.
In this model, there are no dynamics. What we've done is we've so it would be very, you can see that it would be very easy to introduce dynamics by which basically, tomorrow's I think the most natural thing to do would have the effective study type evolve, right? Having the human capital type evolve wouldn't change anything, because things are additively separable. So I could do it, but it wouldn't, give you some interest. It wouldn't give you interesting, let's say, intertemporal substitution of study time, right? I mean, it would just sort of give you a little bit extra study time in the first semester, and that's kind of okay. But what we did something to sort of talk about that a little bit. I'll talk about it a little bit later. Okay. Yeah, so it wouldn't be a problem, but we haven't done it here. Okay, so the best response function maximizes per period utility. So we get this form. So this form is basically an intercept that varies between people potentially, and then a term that depends on friend study time. If this is 1, then it's just a slope, right? That also may vary between people, right? Yep, so that's all I wanted to say about that. So then a pure strategy Nash equilibrium study times is just, the intersection of best response functions given the adjacency matrix A and study types mu, which are fixed. And there exists a unique pure strategy Nash equilibrium for the period game. Existence is standard. Then uniqueness is because we have the weak concavity, and then a best response to 0 is positive. And this is supported by the data. Basically, a very small number of observations have 0 study time. It just doesn't seem like people study 0.
That's the weak concavity. That must be a bit harder to convince yourself of, basically.
Well, we could plot.
I think if you go to the extremes, it's going to look sort of concave. But what you're worried about is whether you have non-concavities.
So I have a picture basically of just a smoothed scatter plot. These are study time hit with noise and the average of friend study time hit with noise, but we'll see. We can sort of assess visually how that is. But you're right. There's always some. If there's a wiggle somewhere, one wiggle is all you need to screw everything up, and that's that. And I'm for sure. Let's just go ahead and say for sure we could reject that weak concavity everywhere. But then in terms of maybe having a model to sort of help us think about what's going on, do we think multiplicity of that order is really the first order economic question? Probably we could also say that it's not. But we'll have this picture actually in a little bit that we can see. Jeff? Oh, no, sorry.
So here, because everything here it goes through the study time.
Yeah.
And that means the average, your friends, the types will not affect the cost factor. So that means you started with smart people or started with not smart people will not affect the cost factor.
There's no ceteris paribus effect, but what their study types will determine So their study type determines their intercept and their slope, so that'll determine their study times, right? In equilibrium. All right, maybe. Is that okay? Sorry. Yeah. So you're right. So there's no. Yeah. So the study type only matters via the study time. You could imagine like contextual effect specification. I'll talk more about why we don't allow for that in the study time equation when we talk about the specification test.
Yeah, so is this also the efficient like study times people assign?
Sorry.
Well, given the network structure, if like a social planner comes in,
Yeah.
it doesn't change any of the
Yeah.
equilibrium study times, right?
Social planner. What's the objective of the social planner?
Oh, I mean, is it the efficient?
What?
Huh?
So people are optimizing. Yeah. So if
Yeah, I guess my question is just, is your equilibrium study time the efficient study time?
so given who's
Given
friends
the
with
network
whom,
structure.
yeah, there's no
Right, so.
efficient study times. I'm a little confused. So I mean, yeah, there's no source of.
Yeah, I'm just asking. I think it is. I mean,
Yeah.
is there any inefficiency?
We don't have
I
an
don't think so.
externality.
I mean, there's
an externality.
I mean, it's a game theoretical model, so in that sense, like, there's always, you're not taking into account how your actions affect other people that in the way the social planner might. But I don't know what, you have to tell me what the objective is that you're maximizing then in order for me to talk about efficiency, right?
Welfare to maximize total welfare.
So utilitarian, planetary
So I think it's probably not going to be efficient just because you would probably want to force people to study a little bit more. But I mean, that's like a very, like in almost any game theoretical formulation, it's going to be, so that, okay.
Yeah, with externality.
Yeah.
You won't get efficient.
Right, but I just want to make sure I wasn't missing something. Okay. So, but maybe there's a more maybe there's another question we can ask, which is if you could sort of switch friendships around, would more be produced? We look at that a little bit. Okay. So here's a slide, some of which I hit on, but I think it's good to do it again. So our specification might seem, that seems a bit spare. I think would be Spartan, right? So when we were developing our model, we really did think about what we thought would be most important in our context, and our proposed mechanism was that friend study time affects your own study time and thus achievement. That seemed pretty first order ex ante, and that there were some other mechanisms that had received attention in academic peer effects that weren't really as likely relevant here. One was contextual effects, which maybe this is people, it seems, very rarely have a specific story for why there should be contextual effects in our minds. We thought of human capital spillover, so you're around people who know more, then their human capital types might enter your achievement equation, for example, right? So we allowed for that in two different ways and didn't really find any evidence for it. What we think is happening is that when people find evidence of contextual effects, they're missing maybe an input choice like we have, but we don't know. That's just a conjecture. Okay. Production complementarities, which I think relates a bit to what you guys were talking about, right? So what we mean here is that the marginal product of my study time might be affected by my friend's study time, okay? In particular, you'd think that they study more, then that increases the marginal product, although maybe you all study more, but then you just goof around. It's not obvious, right? This is a mechanism considered in Calvo et al., the restud paper. Our a priori reason not to include it here is that students aren't, you're not forced to talk about your coursework with your friends. In some of Todd and Ralph's other work, they found that freshmen, spent very little of their time talking about coursework with their roommates. You might think there's even less with their friends, but we actually could test this more directly. So we actually just estimate a model with this, but this is our a priori reason for not sort of having that be part of our baseline specification. So just to be clear, we actually test for these types of extensions to the model, and they don't change anything. And it's not even like that we include them and everything's insignificant and we don't like it. It's just that we think that we have a really reasonable model here, and then test for things that other people had, basically when they didn't have the data to distinguish otherwise, it seemed to us. Okay, that's sort of maybe a harder way to put it. So the model gives us a function that maps the JC matrix, who's friends with whom, and vectors to study types into study times. We operationalize that with just a vector xi, which is indicators for black and male, high school GPA combined ACT score, average study hours per week in high school, and expected study hours in college. And it's the same vector for both the study type and human capital type. And then the only reason to write this in this way, like other than proliferating notation, is to show that the outcomes of each student are a function of the characteristics of everybody in the matrix, right? That's it, right? Oh, everybody who's connected, rather. Right? So in the data, basically in one semester, I think the network is entirely connected, meaning there's one you can get from any student to any other student. I think in the other semester, under some of the different specifications for the JC matrix, it's not connected, like the intersection one, for example, right? So then you have subnetworks, but in general, everybody matters for everybody else's outcomes. That's going to lead us to the specification test. Sorry, that's going to lead us to this slide. But that's going to relate to specification test. So then right, so observed outcomes are really simple here. So GPA, they're censoring at 0 and 4. And study time, they're censoring at 0. And like I said, it's like a very small number of observations where that actually happens, but we just allow for that anyways, or account for that anyways. And the errors are independently distributed, the eta and epsilon. And yeah, this is study time for a report. So if you have multiple reports of the student in that same semester, then they're treated as basically independent observations of the same underlying economic object because there's nothing else that's changing within the semester. Okay.
Why do you have multiple reports?
The survey was conducted multiple times during the semester. And so, so they're up to 4 surveys. A student may have answered up to 4 surveys in the semester. So we actually have multiple reports of friendships as well, but there's one that's like the day after classes start. It's not really that useful if you want to think about the input choice of the whole semester. So we use the survey, the friendship survey at the end of each semester. Okay. Okay, so the likelihood just puts it all together. So here's the model. So the model fits pretty well. I think. So yeah, okay. So here's this actually relates to the other question, anyways. So this is a picture of friend study time. So this is the average over like approximately 3-4 observations for each student, right? Red is observed versus own study time. So this is not the best response function because these things are measured with noise, right? But this is something that's sort of a cousin of the best response function, right? So in the red, we see that, it's increasing, right? This is the smoothed scatter plot, okay? The blue is what our model simulations give us, which is very, very similar. And this is not something that's actually directly entering the likelihood. So it's sort of, it's not really the hardest test of any model ever, but it's nice that we were able to fit this, even though it's not something that actually directly enters the likelihood. So we see here for the concavity, right? That we have, if you want to look at that little bit right there, if you took that seriously and said that that was not just some smoothing error from the smoothing polynomial, that maybe there's a non-concavity there. But yeah, I'd have to.
Can you reject the convex function?
Can you reject the convex function? I don't know. I haven't checked, but that would be a good thing to check. Yeah, this is again, these smoothing things. It's like I don't remember what the bandwidth that R chose to put it's like I'd want to do a more serious.
So there's a lot of variance. So
yeah.
So the average kind of looks encouraging, but it also
Yeah.
looks like I can draw a convex function that wouldn't violate the thing too much.
Right. So there are probably other implications of multiplicity that you could check for. That to engage a bit more seriously about that, we could talk about that maybe a bit more later. But I think there will be other empirical implications of multiplicity that, but yeah.
This isn't exactly a best response curve because it's just mapping each individual
That's
to
sure.
a point. They all have different best response curves. So
That's right.
it's
That's right.
Not.
That's true. That's true.
It's not really going to tell you anything about each individual's response.
That's true. You'd have to look at like an individual between semesters and sort of plot it out, for example.
So there's really no way to estimate concavity with the data.
Because you have only 2 points for each person. That's true.
Exactly.
But it's more than that. Your likelihood, if you do a multiple equilibrium, the likelihood function in general is not defined. You cannot estimate something and then like with like maximum likelihood take the results and then do any testing.
No, sure. Right. Right. If you don't have estimates, then you can't use those estimates to do something, right? For sure.
No,
But I mean,
those dots, anything that you've got out of your estimates cannot be used because you've already assumed.
This is
Yes,
just
but
plotting
this
the
is not a
data.
business plan.
That's just
No,
plotting
no.
the data.
Yeah,
Okay.
no,
Yeah.
it's not. It's not.
Sure. Yeah. So I could look at the right. So the good answer, I guess, would be that I only have 2 semesters, so I can't reject weak concavity, right? Because I have at most a line for each person. Right.
Is the best, can you model, is the best response function heterogeneous for each person?
Yes. Yeah. Right. So actually, okay. So here, here's the estimates for the production function. There's just one parameter, right? I mean, there's a study type, but that's pretty standard. So the marginal product of own study time is a quarter. So increasing your own study time by an hour per day increases GPA by a quarter point. And standard deviation of GPA is 0.8, right? So basically, this is actually pretty similar to the results that Todd got in some other work where they use an instrument, basically video games, to shift how much you're studying and trace out the marginal product of study time. So, but we're using different variation. Like we're not using that variation. So it's kind of nice. Human capital types are higher for students with high school GPAs and combined ACT scores, and they're lower for Black students. Okay, so here's a plot. Now this is all of the model, okay, of best response functions. Okay, so here's the best response function, this green line down here, for the lowest effective study type. Okay, basically the least studious person. So it starts, so these are not constrained to be the same, but they're basically all around the same intercept, okay? But the slopes are very different. So this is the least reactive person, reactive meaning slope now, because they're basically estimated to be linear. So then we can just talk about slopes, okay? Instead of, all right, derivative of the mean or whatever, right? So that's kind of nice. So this is the person with the shallowest best response function in our economy. And let's say this person right here in red is the median slope, right? So where they hit the 45-degree line, that's where they would study in equilibrium if they were paired with only one person exactly like them, right? So we see that the lowest best response person would study maybe 1 3/4 hours when paired with somebody like them, where the median would study 3.5, like twice as much. So, so there is a lot of heterogeneity in the peer effect. We find it to be significant. I have some supporting slides about that. I'm not going to get into right now. But what really matters is who's actually friends with whom, though, right? How important, how often people are actually friends with people like themselves, right? So our baseline specification fits the data as well as more complicated ones, like including contextual effects, complementarities. I'll briefly talk about dynamic behavior. No. You know what? I'll talk about this at the end if I have time. But we've estimated a lot of alternative specifications and basically don't find very big changes. Yeah.
What about other networks?
Oh.
You have who's in classes with one another and things like that. You try. That'd be another way of thinking about a network for study partners, rather than a sum of friends.
So we could go back and actually find who's in the same section. We don't have those data available. Okay. Yeah, but yeah, we could do that. I mean, the thing about that is that those data are available in lots more. Those data are actually pretty easy to get usually, right? So, for example, in Ad Health, you could actually, or actually, I don't know about that. Like ECLSK, I have work where basically we see who's in the same kindergarten class, first grade class, third grade class, fifth grade class, eighth grade. So actually, those are so. I've looked at some other stuff. I mean, they're like those are elementary school students instead of university students in different contexts, but
In principle, you could.
We could do that if we got. got Todd to go back and send him an email. Yeah, that's true. And we could then see. I mean, it's a bit complicated because what do we assume about this network when we look at that one? Right now, we're basically assuming that this is the way in which social interactions take place, and the classroom network is not existent. So it's sort of what do we assume about this, knowing that we do think this is relevant now? I'm not sure. Okay. Okay, so we have a specific. Here's a little bit on our specification test. All right, so our basic, our our approach so far has been conditioning on observables, which happen to be better than the observables I usually have in a data set I'm working with. That's what we're doing, right? So the primary econometric endogeneity concern is that there's there's sorting based on unobserved characteristics. We have evidence that it's not just course specialization. We sort of examine for like the share of math and science courses you have, and it doesn't really change anything. It's not surprising because in the first year they have very similar coursework. Okay, and we have data on what we think of as maybe a good propensity to study. So we have what we think of as good propensity to study data, but they might not be any good. So here's a little bit about a specification test, and the basic issue is that because unobserved random variables by their presence might actually bias all of our estimates of things, we might not have any ability to actually detect any such unobserved random variable, right? This is the base, like, how could you use the data that you're using to estimate the model to also make an inference as to the existence of some confounding variable? So here's just an overview. So consider the model with one study time report, one period, so one semester, and no censoring. So everything's there's none of this TOBIDI stuff. Okay, which we relax in the actual implementation. So just let gamma hat be the vector of estimated parameters, and let S tilde be your study time. So we have a study time residual for this person, and then the average of their friends' residuals, and run a regression of the average of your residual on the average of your friends' residuals. Okay. So under the null of proper specification, so this is just an overview, but under the null of proper specification, the error terms in our study time regression are IID. So the true value of beta is 0. Okay. And then our test stat is just simply, the test stat for a test of b equals 0, where b over standard error is has a limiting standard normal distribution under the null. Right. So that's the basic idea. So the claim is that the specification test will have power against alternatives where omitted variables are present. So this is not, we're wording it in a way, we're trying to be precise about just saying about the presence of unobserved determinants of study time. That's what this is about. It's not about endogeneity of the network. I don't even know exactly what that, that's not a well-defined, people use that language in a way, it's endogenous. People are choosing their friends. Right, but what matters is does this kind of unobserved random variable exist, and is that causing an inferential problem? Right, so this is what this test is about, and that's all it could be about. So intuitively, if there are important unobserved variables influencing your decisions, they're going to show up in everybody else's errors via the best responses iteration of best responses in equilibrium, and it's really similar actually to how in a spatial autoregressive model. What you do when you solve for equilibrium is basically just pre-multiply by the inverse of the matrix, right? And then what that's going to do is it's going to hit even like an independently distributed error. It's going to induce cross-sectional correlations, okay? And what that's going to mean is that once you transform the error by solving for equilibrium, which you don't have to do by matrix inversion, but you can do via best responses or whatever, right? Iteration, right? Then this thus transformed error must be perfectly orthogonalized by the matrix P multiplying it in order for there to not be any resulting cross-sectional correlations that are detectable. So it doesn't matter, they could be negative, they could be positive, whatever. It just, there's like a knife edge set of cases where those things are going to perfectly cancel out. Okay? And here's an example orthogonalizing process. This is just an example, there are many other ones, okay? But using our estimates of our parameters and the friendship matrix in the first period, the ratio of the average covariance between friends to the average variance in the unobserved determinant would have to be negative 0.31. That's just an example that we worked out. But the particular thing to notice is that that's negative sorting. All right, so it's people who are dissimilar being friends with each other on average, which is a bit. This is not a proof that therefore this is not happening in our environment, but this sort of suggests that this is the kind of scenario, right? Things need to cancel out in order for them to not be detected. And for them to cancel out, what you need is, on average, friends to have characteristics that are unobserved that are the opposite of their own, which is not really the most salient concern, people in this literature.
I thought you said you weren't going to use A1 because that's right after the start.
Oh no, A1 is the first semester. Sorry, the time period. Sorry, yeah. So I guess. Yeah.
So this is your answer to, broadly speaking, the reason why you think that there are these peer effects in study time is that you see in the data that when the group of friends reduce their effort, the friend in question also reduces his effort. Right?
Yes.
The obvious alternative hypothesis would be they were all hit with a common shock.
Right.
There was a game on or something like that.
Right.
This seems to be answering this question of, can't I just understand the data as you have it as a particular correlation in shocks that are generating study variance? And it's not that there are any clear effects, it's just they're subject to common shocks.
Right.
You're somehow, is this your answer? Is this...
Exactly. This is saying that we don't believe that these common shocks are what's causing this correlation between friends' observed outcomes, students' outcomes and their friends' observed outcomes. That's right. This is our answer to that. Yes.
But in principle, if I'm perfectly willing to adopt the idea of negative sorting,
yeah, that's right. I mean, it would have to be a very specific case of negative sorting where things have to perfectly cancel out. But yeah, that's right. The other way to put it is that if you are not unwilling to adopt negative sorting, then maybe you'd be very comfortable with this, and decreasingly so. But it's still like a very specific. I don't want to measure zero, but it's like a very specific set of cases.
So yeah.
I can be more explicit about that, but it takes some time.
It would be nice to sort of have an idea of exactly what the identifying assumption is. So what you're saying is, you can by having exactly negative sorting, you can completely exactly that particular one.
Good.
You can completely explain away any peer effects. That's what you're saying, right?
No. What I'm saying is that take the correlation between a student's study time residual and their friend's study time residual. This may be computed using bias parameter estimates because there's some unobserved. All that's in there. Okay, saying that if you have allow the unobserved random variable that we don't see, allow that to have a correlation between friends. If in that particular case, if there are just two students, there was a pair of students or a dyad, a list of dyads, right? Then basically them having a negative correlation of this would cause you to not be able to detect said unobserved determinant of study time. That's all this is saying. Okay? So the opposite, right, is that anything else in this list of dyads example, it would be detectable. And if it is detectable, then if we test for it and don't detect it, then we may, with some confidence, say it's not there. So it's a bit... Okay.
You should wrap up that.
Oh, man. All right. Okay. Well, you know what? But that's... I hope that was clear. I'm going to...
One bottom line.
Oh, man.
Factual or something, and then wrap up.
All right. Okay, I'm going to talk about this one right here. So what we did is No, I'm not. Sorry, I'm going to talk about this one. No, this is okay. So what is the effect of homogenizing friends, right? So this answers the question sort of puts everything together. All right, and what we do is we compare our baseline achievement to achievement under sort of ex-ante homogeneous friendships, basically where we randomly assign friends, hundreds of times, and then see what outcomes are, how they're different. Okay, so what do we? So this is just reports on the average difference across all these simulations. So let's look at women and men. So females were more studious in the baseline than men. So we see that in the counterfactual, they study less because they have less studious friends, because now they're homogenized to basically have more male friends. Males do the opposite, but women also have steeper best response functions, so their gains are their losses are their losses are larger than men's gains because of the supermodularity that's not being taken into account, like not being exploited as much, right? And we see that overall, unsurprisingly, then total output is lower when we have randomly assigned friends than people sorted in friendships. Okay, that's sort of the basic takeaway that I think puts together a lot of the results from this paper. We also have computed, but I'm not gonna. If you ask me during the break, I'll show you. But we also computed basically a output under networks where we just paired off students, like starting with the steepest best response slope, made those two students friends, the next two, just to get a basic idea of how big it could be if you had some bizarre, kind of like a relentless plan that just wanted to maximize output and nothing else, right? And it would be much higher. And actually, this is kind of, I think, comforting, because you would think that people sort of choose friends to maybe, increase output a little bit, but not. They have more than one thing they're doing as freshmen in college. So this is sort of the upshot of our results. Sorry I went over, but yeah.
All right.
And
Thank you.
Thanks.